Hey there, welcome, or maybe I can say welcome back to this module on configure code scanning on GitHub. In today's software development world, keeping your code secure is more important than ever. This module introduces you to the concept of code scanning, a powerful way to automatically check your code for security vulnerabilities as well as errors before they make it into production. By integrating code scanning into your workflow, you can catch issues early, reduce risks, and build more robust applications with confidence. Throughout this module, you'll discover how to set up and optimize code scanning using GitHub's built-in tool, including CodeQL, as well as third-party integrations. Whether you're new to code scanning or looking to enhance your current practices, you'll learn practical steps to enable scanning, configure it for your repositories, and understand the benefits it brings to your development process. Get ready to make your code safer and your development pipeline smarter. My name is Peter Detender, a lead technical trainer here at Microsoft with a passion for DevOps, or should it be better said, DevSecOps. Let's kick off by exploring what code scanning is all about and why it matters for developers and DevOps engineers. Code scanning is a process that automatically checks your code for security vulnerabilities and errors, helping you catch problems before they reach your user. In this module, you'll discover how to set up code scanning in your GitHub repositories using powerful tools like CodeQL, but also third-party integrations and integrating GitHub Actions. By learning to configure code scanning, you'll be able to optimize your workflow and obviously ensure your code is always in top shape. Throughout this module, you'll gain hands-on experience with enabling code scanning, running CodeQL analysis using GitHub Actions, as well as CI tools, and configuring scans based on different triggering events. You'll also learn to compare scheduled scans with those triggered by specific events, giving you the flexibility to really tailor code scanning to your team's needs. By the end, you'll be equipped to build a secure development pipeline that proactively identifies and prevents vulnerabilities, making your software safer and more reliable for everyone. Now, what is code scanning? Code scanning is like having a security guard for your code. It automatically checks your work for vulnerabilities and errors before they can cause trouble. With GitHub's CodeQL, you can analyze your codebase for security risks and coding mistakes, and any other issues found which are getting displayed right in your repository's security tab. Setting up code scanning is pretty straightforward. You just head to the Security tab in your repository, select Setup Code Scanning, and you choose the default option to enable CodeQL. Once enabled, code scanning runs automatically whenever you push changes to protected branches or when you open pull requests, ensuring your code is always being watched over. One of the great things about code scanning is its flexibility and cost-effectiveness. For public repositories and self-hosted runners, it's completely free, while private repositories get a generous amount of free minutes and storage. If you need more, you can adjust your spending limits, which means monthly billed accounts start with a default limit, but invoiced accounts have unlimited capacity. And then for those who want even more control, advanced setup options let you customize workflows and add extra steps. And then CodeQL supports a wide range of programming languages, including C, C++, C#, Go, Java, JavaScript, TypeScript, Python, Ruby, Swift, and so many more. This makes it a powerful tool for keeping your project secure and reliable no matter what you're building. CodeQL is a powerful tool that treats your code as data, allowing you to search for security vulnerabilities searching for bugs, as well as errors by running specific queries against a database extracted from your codebase. Imagine being able to ask questions like, where could a security flaw hide in my code? And then instantly get answers. CodeQL makes this possible by modeling your code structure and logic as a searchable database. You can run standard queries to catch common issues, or you could also write custom queries to hunt for specific problems, with results getting highlighted directly within your source file. This approach not only helps you find and fix bugs, but also gives you deeper insight into how your code is behaving. One standout feature of CodeQL is variant analysis. If you discover a security vulnerability in one part of your code, CodeQL can use that as a starting point to find similar issues across your entire codebase, or even across multiple projects in different repos. This ensures that threats are fixed everywhere and not just in that one single spot. CodeQL databases contain rich, queryable data like abstract syntax trees, data flow graphs, and control flow graphs, really tailored to each programming language. With its object-oriented schema and support for query suites, collections of queries organized in YAML files, what it means, CodeQL empowers you to efficiently analyze, understand, and secure your code at scale. Now, how does the analysis work? CodeQL analyzes your code by following a clear three-step process: preparing the code, running queries, and interpreting the results. So first, it creates a CodeQL database by extracting key information from your codebase. This involves monitoring the build process for compiled languages or directly analyzing source files for interpreted languages. All the necessary data is gathered into a single directory, forming a comprehensive database that then represents your code structure and logic. This preparation step is crucial because it sets the stage for powerful, targeted analysis. And then once the database is ready, CodeQL runs queries written in specialized, object-oriented query language that we call QL. These queries can then be executed using the CodeQL extension for Visual Studio Code, or even triggered using CodeQL command line interface, which I will show you both in the demo later on. And they're designed to highlight potential security vulnerabilities and coding errors directly in your source files. You can use standard queries to catch common issues or write custom ones to address unique concerns within your codebase. The results are easy to understand, giving you actionable insights to improve your code security and the quality of it. And then obviously by automating this process, CodeQL helps you proactively identify as well as fix problems, making your software safer and more reliable. Now, before CodeQL can analyze your code for vulnerabilities, it needs to prepare a special database that represents your codebase structure and logic. This process starts by installing and setting up CodeQL command line interface, and then from there checking out the exact version of the code you want to analyze. For compiled languages, CodeQL watches the build process to extract relational data, while for interpreted languages, it runs directly on the source code. All the necessary information is then gathered into a single directory, forming a CodeQL database that's ready for deep analysis. Setting up the CLI is straightforward. Download the CodeQL CLI bundle, extract it, and then run the executable to start using commands. You can verify your setup with commands like CodeQL resolve QL packs and CodeQL resolve languages, ensuring everything is configured correctly. Creating the database is as simple as running CodeQL database create, where you give your database a name, followed by the language parameter, and each extractor has its own configuration options for tailoring the process. The resulting database contains relational data, copied source files, and a language-specific schema, making it a powerful foundation for running queries that uncover security issues and coding errors within your project. Now, running the actual CodeQL queries is where the magic of code analysis happens. CodeQL offers two main types of queries. You have alert queries, which highlight specific problems in your code, and then you also have path queries, which trace how information flows from one part of your code to another, really helping you spot vulnerabilities like data leaks or maybe insecure input handling. These queries are written in that QL language, which again is a declarative, object-oriented language specifically designed to analyze complex code structures. You can run them using the CodeQL extension for VS Code or using CodeQL CLI, making it easy to integrate powerful analysis into your already existing workflow. Each CodeQL query is stored in a QL file and includes metadata to describe its purpose and guide how results are displayed. The queries use logical formulas and support features like aggregates for concise, effective analysis. Path queries are especially useful for visualizing how data moves through your codebase, helping you understand and address potential security risks. By organizing queries into templates and modules, you can customize your analysis to really fit your project needs, ensuring that your code is not only functional, but it's also secure and reliable. And then once CodeQL has finished analyzing your code, it presents the results in a way that's easy to interpret and you can act on. Each alert generated by CodeQL includes detailed information about the problem it found, such as the specific line of code, the tool that identified the issue, what's the severity like, and then even when the problem was introduced. This level of detail really helps you quickly understand not just what went wrong, but also how serious the issue is and where to start fixing it. The results are then displayed directly in your source code, at least if you're using CodeQL extension for Visual Studio Code, making it simple to review and address problems right where you work. Beyond just pointing out issues, CodeQL goes a step further by offering guidance on how to fix them. It can detect complex data flow problems, like how information moves through your code, and provide actionable advice to resolve them. What this means is that you're not left guessing about the best way to address vulnerabilities or errors. By integrating CodeQL's results into your DevOps workflow, you empower your team to build safer, more reliable software, and on top of that, you gain confidence that your code is protected against hidden threats. Now, even with powerful tools like CodeQL, you might occasionally run into challenges during the code analysis. But troubleshooting is, I guess, straightforward with the right strategies. To optimize CodeQL's analysis runtimes, you can allocate more memory or more CPU cores to your self-hosted runners and use a matrix setup to analyze multiple programming languages in parallel. If your codebase is large, consider excluding test code or maybe splitting your analysis into multiple workflows to just speed things up. These little adjustments help ensure that your scans run efficiently even when your projects are growing. And then when it comes to the queries themselves, remember that large or complex predicates can slow things down, since CodeQL evaluates queries from the bottom up using standard database operations like joins and projections. If you would encounter issues, you can enable debugging in your workflow by setting the debug equals true in the initialization step. This will generate helpful artifacts like more detailed logging, databases, and serif files. These debugging artifacts provide super valuable insights into what's actually happening under the hood, making it easier to pinpoint and resolve performance bottlenecks or even finding errors. With some of these troubleshooting techniques, you can keep your code scanning process smooth, reliable, and effective. The CodeQL CLI that I already mentioned earlier is a command line tool that gives you hands-on control over code analysis, making it easy to integrate security checks into your development workflow. Using simple commands, you can create a CodeQL database that represents the structure of your codebase, running queries to analyze your code for vulnerabilities, and then summarizing the results in a serif file, which is, by the way, a standardized format for reporting security findings. Once your analysis is complete, you can upload that serif file to GitHub, where the results appear as a code scanning alert, helping your team spotting and fixing issues quickly. Using the CLI or command line interface is especially powerful for organization-owned repositories within GitHub Advanced Security enabled, as well as your public projects on github.com. The CLI also provides helpful command line options, so you can easily get guidance on any of the commands you need. By checking out the right branch or commit and setting up your environment with all necessary dependencies, you ensure that your analysis is accurate and relevant. The CodeQL CLI complements the graphical interface on the GitHub website, giving you flexibility to automate security checks but also maintain high standards for code quality across all your GitHub projects. CodeQL code scanning is designed to support multiple programming languages right out of the box, thanks to its auto-build feature. By default, CodeQL automatically detects languages like again C, C++, C#, Go language, Java, JavaScript, Python, Ruby, any of those code in your repository, making it easy to get started with comprehensive code analysis. If you want to optimize your workflow, you can edit the language matrix in your workflow file to explicitly specify exactly which languages to analyze, enabling parallel analysis and getting faster results. For projects with non-standard build processes, CodeQL also offers flexibility through custom build steps. You can remove the auto-build action and then add your own build comments in the workflow file, really tailoring the analysis to fit your unique setup. This is especially useful for complex code bases or when working with languages that require special handling. By customizing your build and language settings, you ensure that code scanning is both thorough and efficient, helping you catch vulnerabilities as well as errors across all parts of your DevOps project. Now, code scanning in GitHub isn't limited to just built-in tools like the CodeQL we've been talking about. You can also leverage third-party solutions to enhance your security checks. One powerful feature is that ability to upload your serif files, which are standardized reports generated by external analysis tools, bringing them in directly into your GitHub repository. What this means is you can run code scans using your favorite security tools, even running outside GitHub, then bring the results back to your project using centralized tracking and alerting. So whether you use the code scanning API, CodeQL CLI, or even integrating GitHub Actions, uploading those serif files ensures that all your security findings are visible and actionable all from one place. The code scanning API provides flexible access to code scanning alerts, analyses, and configurations, allowing you to automate and customize how you manage security across your repositories. By integrating third-party tools and workflows, you can tailor your code scanning process to really fit your team's needs, analyze code in different environments, and maintain a robust security posture. This approach empowers you to catch vulnerabilities from multiple sources, streamline remediation, and build more secure software with confidence. Whoa, that was a lot. But as I mentioned at the start, apart from all other GitHub Advanced Security features we discuss throughout this course, CodeQL is the most complete as it is so versatile in usage, supporting so many different aspects of securing and protecting your code, all using that super powerful QL query language. I think it's more than time to go through a series of demos, showing you different aspects, starting from how to enable CodeQL code scanning, detailing the actions it configures in the background, as well as how to analyze the outcome of a scanning process. And then I'll also show you a bit of the user experience of running CodeQL from within Visual Studio Code, as well as a bit of the CLI. Let's jump back to our GitHub portal and show you in action. So for this demo, I'm splitting it up in 3 different tasks or sections that I want to show you. The baseline code scanning, how to enable it, and then obviously seeing the outcome. Then showing you a bit more details about the CodeQL specific actions workflow. And then last, I'm going to show you what CodeQL looks like in CLI and out of the VS Code extension. If you want to follow along, I have a public repo that's called GH-500 code scanning demo with dashes in between each and every word, just to have it clear, where, as always, you already know where to find the GitHub Advanced Security settings. You would go into the Security tab, and then from here, enabling code scanning. Or if you have the enterprise version of Advanced Security in GitHub, you would go into the Advanced Security settings, and then from there, enabling the code scanning and obviously going through all the options that you do have available here. Once you enable this, after a couple of minutes, typically, it's gonna raise a set of alerts, obviously, depending on your source code. So in this sample repo, if I open up code scanning, it's gonna show me 4 different alerts. I'm gonna grab just one of these, and it's providing me insights. Now, there's quite some, I would say, recognizable components here based on what I explained using Dependabot, but the use case obviously is different. Why? Because now this time, it's not just checking for vulnerabilities out of the packages, which in the end is what Dependabot is doing, but it's now also checking actual source code. So it's really checking all the code inside the repo and identifying any potential misconfiguration in our code base. So in this example here, it's highlighting this HTML construction, depending on library input, might later on allow cross-site scripting, which might in the end break the security of your web application. A little bit further down, you can see the tool that got detected, this case CodeQL, but remember, we could achieve similar things using third-party scanning tool. It's going to provide more details like what is the risk here. And if you open up the more view, it's going to show you the recommendations, providing you some sample code how to make this more secure code. Similar to Dependabot, it's interacting with the weaknesses, the CWEs. And from here, you could open them up, look into the CWE website or web page, where now it's providing you more details, more descriptive, what that cross-site scripting in this simulation actually stands for. If we take a step back, it's going to show us the outcome of the actual workflow. So that's going to be the second part here in the demo. Apart from, again, the security detection, once we enable code scanning behind the scenes, it's creating an actions workflow pipeline where it's called CodeQL. Advanced, where obviously just like any other actions pipeline, you could rename it, you can make some modifications into it, where if you look into the actual YAML file, which I grabbed from the marketplace, would actually be another option. But just by enabling it, this is what you get out of the box. So what we have is the trigger, the push, which in this example means whenever we have an update in the main branch or a pull request coming in out of the main branch and a scheduled task using the traditional cron notation, it's going to run the job. Now, since we're scanning code, it runs an analysis where in this example out of the box, it's using the GitHub matrix YAML syntax, which basically means it allows us to run this against multiple operating systems, where Windows is not part of this, but I have no idea why not. I think it's just an example out of the box. Where then obviously the most important part is starting a little bit further down, where out of the analysis task, we need to identify what is that CodeQL database that we want you to use. And next to that, what is the development framework language that we're using? Now, in this case, you can see that our sample code has two different languages. You could say like the front end, JavaScript, TypeScript, the back end, maybe C# or any other combination of any of these supported languages. We're going to check out the repo like any other pipeline, nothing really new here. That's technically actually moving or executing a git clone task from the repo into the GitHub runner, virtual machine running the pipeline. And then the most important part here is triggering the GitHub CodeQL action, where it's using the metrics language, picking up the different builds. And then from here, if I zoom out and make it a little bit bigger again, all the way down here in the YAML file, it's also triggering the actual action performing the analysis. Where then if we look into the actual code, runtime, I'm going to open up one of my sample runs here. We have two jobs. In the meantime, you know where are the two jobs coming from. We have the C# code scanning. We have the JavaScript code scanning. If I look into the C# one, and I look a bit more into the most important task here, performing CodeQL, you can see there's quite some activity happening here. And then zooming in a little bit, it starts with extracting C#, that's like bringing in the CodeQL database, the queries technically, for the C# language into the runner performing the task. And then a little bit further, it's performing the actual analysis. If we open up the more detailed view, you can see here that it's now loading, mapping it with our repo code, loading the .NET framework, that's all pretty obvious. And a little bit further here, it's triggering a build process, .NET restore, loading the .NET framework, loading the assemblies, and then it's performing the build analysis. So just a couple of details here, where then once our build process is done, that's where it starts running the actual code scanning. So here on the side, these are all different security features where the CodeQL engine is actually scanning for. So those are specific QL, like query language syntax files. I'll show you some of that in the next part of my demo. But these are all the pre-built code scanning tasks, you could say, the database validation using the C# queries coming out of the box, out of the CodeQL framework. Once the scanning is done, it's running the evaluation. And then if I move all the way down, and you can see even for a small sample project like this one, it's now performing the analysis and then providing the actual outcome of it. Analysis is done, extraction is done, and if you want, you can again look into that serif file as well. The JSON file with all the details, all the outcome. And then from here, you have a pretty good view on what's actually happening with my code. What are the code vulnerabilities from a coding or code base perspective? If I bring in my repo in my VS Code, what I did here is installing the CodeQL extension. Now again, this repo is public, so feel free to maybe look into it if you want to get some more ideas about sample queries. I have a few of them, and I'll just open up a couple of them. So opening up my CodeQL, and the way it's structured is up here, you have a section for the languages. Like in my case, I have 2 languages. You could define which ones do you want to scan for. What is the database to be used? And I'll make it a little bit bigger. So there's 2 different options here. One is the default GitHub CodeQL, the same one that I actually had in the GitHub Actions workflow. But then you could also import your own database. I'm using CodeQL CLI for this, so it's basically running CodeQL create database and then pointing to your actual repo, because the database in this case means what is the source code reference that I need to use to scan. The way to do that is go into your database. Once obviously you create it, you would select it, and in this sample repo, it would be the CodeQL file location or folder location in this case. Next, we have the actual queries. And again, I have several different ones where in this example here, I'm going to use example.ql. And what it's doing, it's not, I would say, necessarily checking for actual security issues, but at the same point, it's actually a valid security scanning where it's using the C# language, because this is the C# part of my app. And what I'm going to do here is looking for the page model where it's having a reference to the logging or the logger, but it's not being used. And this is one of the easier scenarios, I think. But what I'm doing is checking if my page model is using the logger, yes or no, because it requires some permission and it could technically be misused. But now in this case, I'm using the logger in my code, but then I'm checking that it is actually being used, yes or no. So the page model here gives me access to the logger, but I'm not technically using the logger, which would be flagged as a security risk. And then the last step is obviously running the query. And again, I got a whole bunch of examples. If you go to that public repo, feel free to have a look into them. There's, for example, the cross-site scanning for vulnerabilities. The SQL injection could be used, but I don't have SQL in this code example. Then we move into the queries, and you could basically select the query, right-click, run against local database, or depending on your setup, you might have different options. When you run it against a local database, meaning, again, the code base from the repo, you can see down here it's performing the scan. Now, to save a bit on demo time, I'm going to cancel this because I already ran it in preparation for my demo, and I ran a few of these, so maybe I'm going to remove the ones with no outcome. And then here on the side, you get the actual CodeQL query results, where it's going to list up all the different parts in your code example, where I got like a contact form that the idea is that you would allow customers to provide their contact details. And that's where I'm having that reference to the logger, but again, not using. There's a little flag here, show results in the problems view. It means integrated again in VS Code. It's going to allow you to pull up. And then the other nice thing is also that it's going to show it right in your actual code base. So here on my onPost action is getting flagged. My onPost delete is getting flagged. And then if you move over, it's going to highlight the root cause of the problem. So in short, that's what CodeQL is about. So started with the baseline code scanning, enabling code scanning, waiting for the alerts to come in, behind the scenes triggering the CodeQL actions where you got some fine-tuning options if you want, because they're just like any other actions pipeline syntax. Walk you through some of the details, the detailed steps, and then closing with the experience of integrating the CodeQL extension in VS Code to help you writing the queries, selecting the code languages, importing or creating your CodeQL database, and then eventually running the query and seeing the outcome of it. This module wraps up by reinforcing the importance and benefits of code scanning in any modern software development. You've learned how to implement code scanning using CodeQL, using third-party tools, as well as using GitHub Actions, giving you a comprehensive toolkit for keeping your code safe. The module walked you through describing code scanning, enabling it in your repositories, then running CodeQL analysis in CI workflows, and configuring scans based on triggering events. You also explored the difference between scheduled scans and those triggered by specific actions, helping you choose the best approach for your team. By really understanding these techniques, you're now equipped to build a secure software development pipeline that proactively identifies and prevents vulnerabilities. Code scanning isn't just a technical requirement. It's a strategic advantage that helps you deliver reliable, high-quality software. With these skills, you can confidently safeguard your projects and contribute to a culture of security and excellence within your organization. This brings me to the end of this video, and if you've been here with me since Module 1, it's the end of the course collection. Thank you so much for the time you spent here, learning about all the great features GitHub Advanced Security has to offer. But remember, there are many ways to continue your learning journey. We encourage you to watch other videos in this course or search for your next favorite topic on Microsoft Learn using aka.ms/learn. Second thing to remember is that after you got enough practical experience, consider signing up for the GitHub Security Certification. It might not give you an immediate pay raise or a promotion, but at least you will be able to sleep well at night, knowing your company's repos are well protected and secured. Till next time, friends, take care.